I didn't see you there.
Yeah.
Did you find what you're looking for?
No, I will have to look for it in the garage later, but look what else I found.
Oh. Yeah, thank you. Yes. Yeah, this is a plaque from a tank from the World War II. This is a reminder for myself to know how to work with statistics and understand how from one sample I can know how many samples there are in the world.
Oh, really? Never told me about that.
I don't think I could tell you with 4 years old how statistics were working.
I'm studying, Granny.
You're telling me you want to know about the story?
Yes, of course.
Okay. Well, suppose we have a number of tanks and we find in the battlefield this tank number. It's 42. We will call it M. Suppose. And we want to know how many tanks there are because we just found this one. So how do we do that?
Do you think the likelihood estimation, the maximum likelihood estimation, would be an appropriate approach to this?
Yeah, actually, it can help. So let's talk a bit further about that. Now, we already know that the Germans just number their tanks sequentially, giving the first tank the serial number 1 and then counting upwards, so that the newest tank with the number n would have the highest serial number, and that serial number would also be equal to the number of produced tanks. This also means, assuming that we were equally likely to find the wreck or capture any tank with any serial number, that the numbers we find come from a discrete uniform distribution over the domain 1 to n. We found this plaque with the serial number 042 in the battlefield. We can call it M, and whereas the total number of tanks is n, combined with the uniform distribution f of m and the likelihood estimation function L of n, knowing that m, we have everything we need to calculate the maximum likelihood estimation. The question in place is, what is the maximum likelihood estimate for the total number of tanks given our observation? Our uniform distribution f of m is equal to 1 divided by n minus 1. Our likelihood estimation function is L of n, knowing that m1 to mt, which is equal to the multiplication of every uniform distribution of m. Because we only have one observation, our likelihood function will be 1 divided by n minus 1, which is also equal to n minus 1 elevated to minus 1. We derive this and have minus 1 divided by n minus 1 elevated to 2. This function or derivation never takes the value of 0, as dividing a no-zero number, in this case 1, will never lead to a result of 0. This derivation, just like the likelihood function, is undefined for n equal to 1, because that would lead to a division by 0. However, we already know that n has to be at least 1, and it is reasonable to assume that more than one tank exists. We can even be sure of that if the serial number we found is bigger than 1. Now, as the derivative never takes on the value of 0, that means that we do not have any minimum or maximum in this function, because we know that the maximum likelihood function is decreasing. That means that the maximum value of our function will be when it starts. Our start point is m, because n cannot be smaller than m because the tanks are numbered sequentially. So if we find a tank with number m, there have to be at least m tanks. Therefore, the maximum likelihood estimation for n given that we found one serial number m is m. For our example of m equal to 42, our estimate for n would be 42.
So tell me, young lady, was that intuitive?
Well, I think it's quite unlikely that we find one of the last serial numbers of the tanks, and on the other hand, let's say if we find the serial number 5, then we know that at least 5 tanks go before. Therefore, we are underestimating, the total number of tanks.
Yeah, actually that's true. We are biased.
How can we mathematically prove that our solution here is biased? The formula for the bias of theta hat is equal to the expected value of theta hat minus the actual value of theta. Our expected value of n hat is equal to n plus 1 divided by 2. The bias formula is n plus 1 divided by 2 minus n. If we calculate this, we obtain 1 minus n divided by 2, which is unequal to 0, n is bigger than 1, and we know that n is at least 1 because the serial number starts at 1. This means that for n bigger than 1, the maximum likelihood estimation underestimates the true value by n minus 1 divided by 2.
However, you didn't find just one plug, right? You found several ones, and I think you can't use the same formula here, can you?
Actually not. We have to change the formula a bit, adapt it.
Suppose m number of soldiers have each reported a serial number. Our likelihood function is equal to the product of 1 divided by n minus 1 for every n we have. This is equal to 1 divided by n minus 1 elevated to m. The derivative is then minus m divided by n minus 1 elevated to m plus 1. Just like earlier, this function can never be 0, and as our likelihood function is a decreasing function and n can never be smaller than the bigger serial number found, the maximum likelihood estimate is the highest n found. Just like before, it is unlikely that the found serial numbers contain the highest available serial number. Therefore, the maximum likelihood estimator for n, even if multiple serial numbers are used for the estimation, is likely to be biased and underestimate the true n. For an unbiased estimator, let's look at the minimum variance unbiased estimator. This estimator has lower variance than any other unbiased estimator for all possible values of the parameter. We have m, which is the largest observed serial number, a sample maximum, and k, which is the number of observed serial numbers of the tanks, the sample size. For our formula then, we have m plus m minus k divided by k, which is equal to m plus mk elevated by minus 1 equal to m multiplied by 1 plus k elevated to minus 1 minus 1. The statistical methods estimated the production at 246 tanks per month. Between June 1940 to September 1942, at that time, intelligence services believed that the production was around 1,400 tanks per month. Afterwards, the German production records listed the true number of tanks produced as 245 per month.
Oh, that was a really good estimation, wasn't it?
Yeah, I calculated it. Of course, it was a good estimation. Maybe I still have some recordings from when I had to tell to the students of university how we do that math. Maybe we could look at the tapes together. Maybe we find it in the garage, and let's see. Maybe you learn something new.
Cool.
Do you smell something like burning? Oh, my cookies!